A logarithm questions of this form can be solved with these tables of analysis. But the first thing you are going to consider, you see the questions of this form, it said 2, 3, 4, 7 divided by 641 minus 751, 864. These are the steps. If you follow this video to the end, don't skip this video because this solution is highly interesting to solve. So just this how you're going to draw the table. So the first thing you are going to do, you find the value of this, the real value. You get the value of the real value for this without using calculator with the four-figure table. So after that, you subtract and you evaluate. So now, in solving this, you firstly find the here we have 1, 2. 1, 2, 3, we have 3 points. 1, 2, we have a 2 point. So now let's find the logarithm of 23 under 4 different 7. So the logarithm of 23 under 4 different 7 will give us 3705. So now at the same time, the logarithms of 64 under 1 will give us 8069. So now, these are the two logarithms. So because this is dividing this, so automatically you have to subtract with the laws of logarithm. So the first thing we're going to do now is this. 9 minus 5, it is not possible. You borrow 1 from 0, but it's a 0 already. So let's firstly borrow 1 from 7 to 0 to give us 10. So from there, you now borrow 1 from the 10, give us 15. So 9 minus 15, we have 6. We have 6. So 6 minus 9, we have 3. We have 3. So it remains 6 here because we have already borrowed 1 from the 7. We have 6. So now, so therefore we have 8 minus 3 is not possible. You borrow 1 from the 3. So the moment you borrow 1 from 3, we have 13. So 8 minus 13, we have 5. So it remains 2. So 2 minus 2, we have 0. So that means that is 0.5636. So this is the subtractions of this from this. So therefore, in subtracting this from this, so you now find the antilog. But before finding the antilog is times 10 to the power 0. Now you now find the antilog of 56 under 3 different 6. So in finding the antilog of 56 under 3 different 6, our value give us 3.661. That is the answer for that. So the same applicable to this also. You obey the same rule to this. The first thing you are going to do is 2 points. The second thing you are going to do is what? 2 points. So therefore, in doing all this, you follow the same rules. So the same applicable to this. You will now find the logarithm of 75 under 1. So the logarithm of 75 under 1 give us 8756. The logarithm of 86 under 4 is give us 9365. So we are going to subtract again from this. So we have, this is 5 minus 6, which only give us 1. So 6 minus 5 is not possible. You borrow 1 from this. Now give us 15. So 6 minus 15 give us 9. So here it remains 6. It remains 6. So 3 minus 6 minus 6. That is 6 minus 3. It surely give us 3. So now 8 minus 9 minus 8 is not possible, so you borrow 1 from here to this place. It now give us 18. It now give us 9. Now the cut remains 1. So 1 minus 2. It will now give us by 1 point, please. You have to take note of this for you not to have an error on this place. It remains 1 here. So 1 minus 2. It now give us by 1.93. So immediately you want to find your antilog. It will give you times 10 to the power minus 1. That's just the meaning. So the antilogs of 93 under 9 different 1. In finding the antilog, it gives us 8.692. So now we are able to get the value for this by using table. You're able to get this by using table. So let's write it out to have 3.661 times 10 to the power 0 minus 8.692 times 10 to the power minus 1. So, which is all raised to the power 3. So, we have 3.661 minus 0.8692 raised to the power 3. So, this is exactly what we need. So, by subtracting this, we observe that it gives us, so when we subtract, we have 2.7918 all raised to power 3. But to make it easy, because we are in 4-figure table, you try to approximate this to become 2. So we have 2.792 all raised to power 3. So this is now exactly what exactly I want to find now. So we are going to evaluate the values of 2.792 all raised to power 3. So you start again by putting the number and log. You said number and log 2.792. You firstly find the first thing you're going to do is 0 points. So in having a 0 point for this, so therefore you have 27 under 9 difference 2. Recall I've said early it is 2.7918. Because we are using 4-figure table, we must round it back to four figures. So that's why I approximate this to 2. That's why it's not easy for me to do this, to have 27 under 9 difference 2. That is how I'm able to do that. So therefore, the logarithm of 27 under 9 difference 2. By the time I find it, it gives us 0.4459. You know, I've said earlier that you can write this value now. You don't need to represent by anything. In my previous video, I represent the bigger value with a letter. So we shall have 2.792. Now, many people do make mistakes. When you are writing this, it's quite different from this. Somebody will just write this and write only this. You miss it. So you must write raised to power 3 before you applied 0.4459 times 3. So when you multiply by 3, we have, so in multiplying this by 3, we have a 7, not to waste much of our time, and a 1 point. So that is just the value now. So now, you will now find the antilog of 33 under 7 difference 7. So let me try to do the last revision before I finish it. This overall of this, you must be able to understand how to draw your table before solving a logarithms of 4-figure table, of using 4-figure table. So the first we are going to write is times 10 raised to the power 1, this. So you find 33 under 7. And 33 under 7 difference 7 will give us 2.176. So by the time you multiply with this, the final answer will now give us 221.76. This is the answer for this. So it means all these things will give you, overall will give you 21.76. 6. So that is the answer for this. Logarithm is very easy to solve when you try to avoid some errors, which really common. So when you avoid the errors, you surely get the answer. So thanks for taking much of your time to watch this video, and don't forget to subscribe to this channel and share this video. I remain the same to solve any mathematical problems and exercises. Thanks for watching.